In this example, we're asked to determine the critical x values for the function f of x equals negative 6x squared plus 2x plus 1. Well, let's look at this. This is a polynomial, and we had some conditions that needed to be met for critical values. The first was that the function needed to be defined at that the critical value, and the other was that either the derivative equaled 0 or the derivative did not exist. That's how you'd have a critical value. Well, notice something about what we've got. We have a polynomial. Polynomials are defined everywhere, so our job is really going to be to find where the derivative equals 0. It's defined everywhere. So that's our job. So what we're going to do here then is find the derivative, and this is fairly easy. The derivative is simply negative 12x plus 2. So we're going to take that derivative, set it equal to 0, and that should be fairly easy. Negative 12x equals then negative 2. We divide both sides by negative 12. All right. And what do we get as a value for x? Well, x equals 1/6. So this is a critical value. This is our critical value right here. All right. Why? Because at 1/6, the function will be defined. Again, it's a polynomial. And at that point again, the derivative f prime of x equals 0. So this is a critical value. Now let's go ahead and take a look at another example. In this example, we're looking at something that is piecewise defined. All right, we're going to determine the critical x values for the function. Well, again, it's piecewise defined. Really hard to tell from just this what the critical values are, don't you think? Well, that's okay. What we're going to do is we're going to graph this function. So let's go ahead and get some graphing paper. So here's my graphing paper, and let's go ahead and sketch this graph. Okay, so let me see here. Let me change my pen color. There we go. Well, I know that for x's that are less than 0, so that's somewhere out in this area, I'm going to have my graph be negative x. Okay, so let's see here. Something that looks like this. Now at 0, again, I'm going to have an open point. All right, and then when x is greater than 0, okay, so let me change my color one more time. When x is greater than 0, I will have a graph that looks something like this. Okay, and again, an open dot at that point. So they're just reflections. All right, and then the next point is that when x equals 0, I will have a value at 2. So let's suppose that 2 is somewhere right in this neighborhood. All right, so there is my value of 2. All right, so let's take a look. Based on this graph, what are my critical values? Well, let's see here. What can I say? I think my critical value is at x equals 0. Well, why? Let's take a look. It's defined at x equals 0. The value is 2. But the derivative does not exist. Why? Well, it seems that at this point there's a cusp. What else? It's also discontinuous. So therefore, the derivative does not exist. It's not differentiable here. So my critical value here for this particular function, my CV, if you will, is going to be at x equals 2. I'm sorry, x equals 0. And again, the reasoning is that it's not defined. It is defined, but the derivative does not exist.
Made with Doodlecast Pro.